Hi friends, this is Hemadri. I am working as assistant professor in RMK College of Engineering and Technology. So today I am going to discuss about engineering metallurgy. In this alloys and phase diagram, we will see the eutectic phase diagram type 1 and type 2 and the peritectic phase diagram. So first we will discuss about eutectic phase diagram. So here in eutectic alloy system, first we have to draw the cooling curve. In cooling curve, we have to draw with respect to the temperature versus time. So here you take the two different metals with the different compositions, and then here we can observe we are adding one element to another element. The freezing point it is becoming reducing, and then same it is from right side also. So at one point E point, so it is minimum, so both the sides the freezing point it is reducing. At this point, at this temperature, so the entire liquid it will be converted into two solids. So this is called eutectic reaction. So here first we will see the Raoult's law. Raoult's law means the freezing point of one substance it will be lowered by the addition of second substance. So here first one is entirely soluble in liquid state but insoluble when it will be solidification. So this is called Raoult's law. So first we can observe here. So I am taking 100% A, 0% B. So it is a pure metal. So for pure metal it is in constant temperature, entire liquid it will convert into solid. So now I am taking 80% A, 20% B. So then the freezing point it is reducing compared to the pure metal. So again at 60% A, 40% B, the freezing point is reducing. So like this, when I am adding one element to another element, so the freezing point it is becoming reducing. So but at one point of time, so at this temperature, so entire liquid it will be converted into solid. So this point we can call it as a eutectic point. So this is called eutectic reaction. So now we will see the eutectic phase diagram. So here we have to draw the phase diagram with respect to the temperature versus composition weight percentage. So here I am taking A, 100% A, 0% B, 20% B, 80% A, 40% B, 60% A. So 60B, 80A, 80B, 20A, 100B, 0% A. So here the melting point of pure metal is it is at M. Here the melting point of pure metal B is N. So I am adding at different compositions, the freezing point it is reducing. So based on the Raoult's law. So now, so at this point I told you the now, at eutectic point entire liquid it will be converted into two solids. So we can call this as a eutectic reaction. So now we have to mark the various regions in the eutectic phase diagram. So first one is here it is entirely liquid solution above this region. So it is a single phase liquid solution. So coming to this region, so here it is both liquid will be there plus solid A. So that is called solid grains. So solid A grains will be there. So coming to this side, liquid plus solid B. So why it is solid B means, so here the percentage of B is 100%. So that's why the B solid B grains are very high. Now bottom of this eutectic point, so entirely it is in eutectic mixture. So we can call it as a solid A plus solid B. So this is called eutectic phase diagram. So here liquidized line is M, E, N. So that is called liquid S line. Now solid S line is M, F, E, G, N. This is called solid S line. So we have to mark all the regions in the phase diagram. So now we have discussed about eutectic alloy system. So now we will see the at various compositions we can see the microstructural changes. So see how the microstructures it is changing from different compositions. So here left side of this eutectic point we can call it as a hypoeutectic mixture. So right side we can call it as a hypereutectic mixture. So now we will see about eutectic alloy system type 2. So here in type 2 means normally no two metals it will be completely insoluble in each other. So the solidification actually it is occurring based on this temperature. So slowly the temperature it is getting down. Based on this eutectic reaction will happen. So here it is not a pure metal, it is a combination of two metals, that is called alpha plus beta. So in eutectic alloy system we can call it as a partially solid solubility. So the two metals completely soluble in liquid but partially soluble in solid state, that is called type 2 system. So here I am adding one element to another element, the freezing point it is reducing, same like previous one. So the only difference is, so the partially solid solubility, that is two new phases will occur, that is called alpha, and this side is beta. So here alpha means, so the solid grains, that is called B grains, it will be soluble in A, that we can call it as a alpha. So A in B we can call it as a beta grains. So now we will see the various regions. So TA, E, TB we can call it as a liquid S line. TA, L, E, G, TB we can call it as a solid S line. So here this region we are having the liquid plus alpha. So this region we are having the liquid plus beta. So bottom of this eutectic reaction we are having the two phases, both alpha plus beta. Now left side we can have the alpha region and right side we have the beta region. So why we can call this as means, so the solubility limit is very low, that is, so the B composition it is soluble in A, we can call it as a alpha. The A composition it is soluble in B, we can call it as a beta. So this is about eutectic alloy system. Now we can study the various alloys microstructures in this system. So first we will see about alloy 1. So here it is 5% of B, 95% of A. So at this temperature at T1, so entirely the mixture is liquid solution. Now slowly I am cooling. So once it will cross the freezing point line, the liquid S line. So at T4 at this temperature, once the freezing will start, so small alpha grains will form. So this is called alpha solid solution, that is called alpha, and remaining it is liquid solution. Still we are reducing the temperature. Once it will cross this line, so entire liquid it will be converted into alpha. So this is called alpha single phase solid solution. So how it will occur means, so that is called diffusion mechanism. So once we are lowering the temperature, so the liquid range it will less and solid grains it will increase more. So because of the diffusion mechanism. So from this we want to find the liquid percentage and solid percentage. We can apply the lever arm rule and we can find the liquid and solid percentages. So now we will see the another alloy at 60 percentage of B, 40 percentage of A. So at this temperature alloy 2. So here it is entirely liquid. So before eutectic reaction, so it will be liquid solution plus small alpha grains plus beta grains. So both the mixtures it will be there. So once it will cross this eutectic line, so entire liquid it will be converted into like this plate light mixture. We can call it as a plate light mixture. This one we can call it as a eutectic reaction. So next is alloy system 3. So at 40 percentage of B, 60 percentage of A, we can see the microstructural changes. At this point entirely it is liquid. Once it will cross the freezing point at T3, so liquid solution is there and solid grains it will form, small solid grains. Still we are reducing the temperature, so the solid grain size will increase. So once it will cross this eutectic line, so entire liquid it will be converted into eutectic mixture plus alpha and solid solution will be there. That is called alpha solid solution. So this is about alloy 3. And next alloy 4 is at this point it is liquid. At T4 liquid plus alpha solid solution. Why means here the liquid range is more, solid range is very low. Solid grains initially it will form very fine solid grains. Slowly we are cooling. So once it will cross this line, entire liquid it will be converted into alpha solid. So again it will cross this eutectic line. Alpha will be there plus both this beta will be there. This is called alpha plus beta. Both the regions will be there. So this is about eutectic alloy system type 2. So next one is peritectic phase diagram. So here what is meant by peritectic reaction means one liquid plus one solid at constant temperature it will react. It will give another new solid. We can call it as a peritectic reaction. So here we are taking with respect to temperature and composition weight percentage. First one is this is the liquid S line Ta D E T B. Solid S line is Ta Tp G J E T E T B. So here this region entirely it is liquid. So coming to this left portion, so here liquid will be there plus solid grains are there. So here A percentage is very high this side. And then once it will cross this line, this is called peritectic temperature. So entire liquid it will be converted into solid. So plus A solid grains is there. So that is called A plus compound AMBN. So coming to this side, liquid is there but liquid percentage is very low plus this compound is there AMBN. So right side we are having the B percentage is very high. So liquid plus B. Once it will cross this eutectic point, so we are having the this compound plus solid B. So this is about peritectic reaction. So here peritectic reaction means one liquid plus solid at constant temperature it will give the new solid. We can call this as a peritectic reaction. So here we see the microstructure at this temperature alloy 1 10 percentage of B 90 percentage of A. Here it is liquid. So before this line, so here liquid plus solid grains are there. Once it will cross this peritectic temperature, entire liquid it will be converted into solid due to this diffusion mechanism and primary solid grains are there. So the percentage is alpha A, that is primary A 67, and solid compound 33 percentage. So like this the peritectic reaction will occur. So it is called for another alloy. We see the microstructural differences. So how the microstructure it is changing from liquid to solid. So this is for another alloy, alloy 3. So like this we are having the various microstructural changes in peritectic system. So today we have discussed about eutectic reaction and eutectic alloy system type 1 and type 2 and peritectic reaction. Thank you.